So this is part 2 of nucleophilic addition reaction. So let's go ahead and try this problem over here. Let's say we have this ester over here, and this is ET, which stands for ethyl group. Okay, you can try any group over here. Let's see. Let's say we reacted with CH3 MgBr, the Grignard's reagent, and in the second step we protonate it with hydronium ion. So let's look into the mechanism. So what will happen? This, who's the nucleophile? So what will happen over here is this. The CH3 is the nucleophile, right? So CH3 from here will attack on this carbonyl carbon, okay, pushing the bond towards the oxygen. It's pretty much same thing, so it's quite predictable at this moment. You can predict the things what are happening over here. Oh, sorry, I just drew it here. Me- yeah, it's over here. So this will be pushed over here, so negative, and then you have over here OET, and this CH3 will add over here. And what would be the next step? Let's say uh, this will be moving down and kicking this, because this OET is a better leaving group. So what will be the result of that? So this will be your product after this move. So you have a double bond O, and then you have this CH3. Okay, then what will happen? The more CH3 MgBr from the solution will go ahead and react with this carbonyl carbon. So this CH3 is going to attack on this carbonyl carbon, the electropositive site over here, and it would generate this thing. When it will attack over here, this bond will be pushed on the oxygen, so generating O negative ion, and you have over here another CH3. Okay, so what will happen next is this thing. So this will be we will be reacting with the hydronium ion. Okay, so now this CH3 is not a good leaving group. Okay, so it can't be made to leave. So what will be the next step? We will protonate it with the hydrogen from the hydronium ion. So let's go ahead and write it like this. Okay, and this will be having this because oxygen is positive here. This oxygen will be grabbing this hydrogen, and what you have is this thing. Uh, this will be your OH. So you have tertiary alcohol over here with you. Okay, you started from here, and then you have the tertiary alcohol. So you successfully reduce the ester to this alcohol group. Let's look into one more example. Let's say we have this acid chloride and we're going to react it with sodium boron hydrate. Okay, and then this is the first step, and second step we are going to protonate it with this hydronium ion. Let's go into the mechanism and then write the final product. So you have this acid chloride, Cl. What is the nucleophile from here, as discussed in the part 1. So this is your boron hydride. This boron bears a negative charge. Hydrogen is more electronegative, so this will go ahead and make the attack on this partial positive site. So this will be the thing, this will be pushed here. So for now, you must be able to predict the things, how they work over here. And you will go ahead and add hydrogen over here, and this is chlorine. So acid chlorides are more reactive than your esters, because chlorine is a better group, leaving group than OCH3 or OR. Okay, so this will be pushed down, and the Cl will be made to leave. So what would be the result of that? So you will have this aldehyde over here, double bond O, and then you have this H. Okay, so what will happen next? So you will have more sodium boron hydride from the solution if you have left. Okay, and then what will happen? This will go ahead and make the attack on this one, right? So the another hydrogen will make the attack. So let's say this hydrogen go ahead and attack over here, this carbonyl carbon, which is electropositive, and I will write the result over here. So as a result, this will be pushed back. Okay, and then what would be the thing? This oxygen will be a negative charge. Okay, and you will be adding one more hydrogen over here, right? So you know that hydrogens are not good leaving group, and this oxygen will not be able to push its electron back, so it will grab the hydrogen from the solvent, okay, like this. Just one second. Yeah, OH2. Okay, so this oxygen bears positive charge. It will grab this one, making this hydrogen leave, and this hydrogen will be grabbed by this oxygen, as we've done quite a few times now. So this will be your alcohol over here. Okay, so these are your two hydrogens which have been added. Okay, let's look into some more examples.